Stats for STEM. This is a video on running a independent samples t-test. This is a scenario in which we have a treatment and a control group. And this is where we would have a scenario where we're testing one group against another based on the means. This would be after I've given some kind of a quantitative measurement, like a survey or a test, something that has measured something. So I'm going to test one group against the other. In this scenario, this is a scenario dealing with math attitude. And this is a situation where we have implemented a tutoring program. And so we're looking to see if there's a significant difference in math attitude between two groups of middle school students who, one who attended math tutoring and the other who did not. That's our independent variable. So our dependent variable is math attitude. Independent variable is the grouping, or we could say the presence of math tutoring. So the control group just went to class. They didn't have any tutoring, nothing special. And the treatment group went to maybe after school math tutoring or lunchtime math tutoring, something like that. So what I've done really here is I've just created a couple sets of data, and I've calculated the mean and the standard deviation using formulas there from Google Sheets. And then same thing over here for treatment group. I did the formula for the mean and then the standard deviation. These histograms over here I created, and I've done previous videos on those, so I won't take the time to go through how you create those histograms. You can go back to the video on normality and histograms. I also did these graphs in the video on dependent t-test. And so you can go back and watch those videos on how to create the histograms. But I've already done them here, and it looks like my data for the control group is pretty normal. I've put the normal curve here. I've got my histogram, my bars with my data, and then I've got my treatment group histogram showing the data is relatively normal, not too far off. So let's go ahead and just run this t-test and see what we get. We're going to look at whether there is a statistically significant difference between these two averages. Now, if we look at them, we could look at this and say, well, 14.4, that's higher than 12.8, but we don't know if that difference is statistically significant. We don't know if the difference is due to circumstance or coincidence, or if it's due to the thing that we implemented, which was the math tutoring program. If we've controlled the scenario good enough, we can say that it was due to our intervention, which was math tutoring. So we're going to go ahead and run a t-test here. Again, I'll run this three ways. The first way is to use Google Sheets, and I'm going to hit equals and then run a t-test. And this is only going to give me the probability of the differences of the means being statistically significantly different. So it asked me for the first range. So I'm going to grab my first range of data here. And enters it in there. I'll hit comma. It asks me for the second range, and so I will highlight that second range and hit comma. How many tails? I have 2 tails, and this is going to be a type 2 test. There are 3 types of t-tests. There's the type 1, which is dependent samples, where you're sampling the same group of students again after intervention. This is a independent samples. So we're testing 2 groups here. And then the third kind is independent samples, where we don't assume that the mean is the same. In this case, we're going to choose number 2. Close the parentheses there, and I'll hit enter. And it there has given me the significance level, which you can see is very far below 0.05. So we're always looking for a p-value less than 0.05 that would allow us to reject the null hypothesis. So this is saying you have way less than a 5% chance of being wrong when you say that there is a statistically significant relationship here. So in this case, we would reject this null hypothesis that says there's no difference. Based on math tutoring, we say, no, there is quite a difference, and that is statistically significant. In fact, when we say that, there is less, there's less than 1% chance of us being wrong when we say that it's math tutoring that made the difference. Let's run this another way. We're going to use Excel Miner, which is an add-in I've shown before, Excel Miner Analysis Tool Pack. It's a free add-on. And let's hit start on that. It's going to ask us for basically the same information. And I'm going to scroll down here. I'm going to go down to t-test. 2-sample assuming equal variances. We assume that the variance in the data sets are about the same. I'll choose that one. It'll ask me for the range values. So let's go up here and we will highlight, and I'm going to include the label on that column. So we will pop that in there, and then I'm going to include the column heading there as well, put that in for the other range. The hypothesized mean difference. My hypothesis says there's no difference, so that would mean I'm saying there's a difference of 0. I'm going to click on the labels box because I have control and treatment part of that range. The alpha is 0.05. The output range, where do I want this output to land? I'm going to click on a cell down here and then click on the output range. It'll tell it to put right there. Hit OK. And now this gives us a little bit more information than we had before. There are the means for the control and treatment groups. We knew those already. The variance is related to the standard deviation, but it's not the same value, but it does give us the variance there. And we have 20 observations. Let's scroll down here to what we really need. Here's the T statistic. That is the main outcome of that formula. And if you look down here at the two-tailed p-value, it is right here, and it is the exact same as the other one that we got on Google Sheets a moment ago. So those two values right there are very important. And there's our probability value. Once again, matches up to what we had on Google Sheets. Now let's do this a third way because I want to do one extra thing, and that is to find the effect size. So we're going to go to Social Science Statistics. That's this website here that I've used a couple different times. And we're going to go up here to Calculators. And we're going to choose T-Test. And we want 2 independent means this time. So we'll open that one. It'll give you the formula here if you're interested in working it by hand. Then enjoy doing so. But otherwise, we'll have the calculator do that for us. And it's going to ask us for the range of the treatment value. So let's pop back over here to our data. And this time I'm not going to include the headings. I'll just get the data. Control C, copy that, pop that into the box here. Same thing with my second treatment. Let's go over here to our treatment range, select that, Control C, paste that into this box here. Significance level of 0.05 is what I want, and I want a two-tailed test. I want a two-tailed test. And then I'm going to tell it to calculate TMP values. And here we go. Let's see what we got. So this will walk you through all the values from that formula. So if you did ever work it by hand, you could look and see if you've done it right here. But this gives us the main output down here, and all these values are part of that formula. And here's the stuff we're interested in here. The T value is 0.366. We had that value before. There's the P value, and it reminds us that this is a significant result, which we kind of already knew. But I'm gonna copy that, put that over here. But we're gonna do one extra thing here that is important when we're dealing with means testing or even correlation, and that is to calculate the effect size. We want to know a little bit more. We want to know how much math tutoring affects the average or that mean score there. We want to know the effect size of this math treatment, this math tutoring. And the way to do that is to use another formula, another calculation, and Google Sheets doesn't do that for us. So I'm going to pop back over here back to the t-test, and it'll tell you if you wish to calculate the effect size, use this calculator right here. And so it's all set up for you to do that. So let's go ahead and click on that, and it's going to want to know the mean, the standard deviation, the sample size. So I'll go back over here to my sheet, my control group. The mean was 12.8 and the standard deviation 1.34. So let's see if I can remember those two things. 12.8 and the standard deviation was 1.34. And I had 20 people in that sample. Now for my second group, my treatment group, the mean was 14.4 and standard deviation of 1.27. So let's put those in real quick. 14.4, standard deviation 1.27, and again, there were 20 people in that group as well. All right, and let's hit calculate on that. And it will go through, again, another formula that compares basically the standard deviations against the means and gives us a statistic that tells us how powerful the intervention was. And so there's the data I entered in, and the one that I'm really interested in here is Cohen's D. This is a pretty very well respected and very common effect size calculator. And the output of that is 1.22. So I'm actually just going to grab that number and I'm going to bring that over. So 1.22 is a very large effect. In fact, it would be a very large effect size. And so I could come out and say, not only does math tutoring work, it works. It has such an effect that students who take math tutoring and their grades are 1.2 standard deviations above their peers who didn't take tutoring. And so that is a little bit more information than we were provided in any of the other calculations there. And so it's a very valuable piece of information. So this would be considered it probably is very high. I'll just put a high effect for now. And so that is all this information right here is what I would be reporting as far as this output goes. So in this video, we've done a independent t-test. We had two groups, a control group and a treatment group, and we have done histograms to show the data, and then we've run a t-test 3 different ways, getting the same probability that it is a statistically significant relationship. And it looks like if students go to math tutoring, we can say with a pretty strong probability that they're going to do better in their math attitude. And the effect size of that output is 1.22, which is a high effect. So math tutoring appears to have a pretty high effect on math attitude.